In this video, we are going to be examining the Lewis diagrams of covalent compounds, also known as molecular compounds. To remind ourselves, a covalent compound is a compound made up of two or more nonmetals, and they share electrons to become stable. Lewis diagrams are more complicated for covalent compounds than they are for ionic compounds. And there is a set of rules that we need to follow when we are drawing Lewis diagrams for covalent compounds. The first thing that we want to do is add up all the valence electrons in the compound for each atom. We're then going to draw a structural diagram. And the way that we're going to do this is we're going to put the element with the lowest valence number in the middle, and we're going to spread all of the other atoms around it. The only exception to this rule is hydrogen. We never put it in the middle. We're then going to use 2 electrons between each pair of atoms to make a bond. 2 electrons is always 1 bond. Then we're going to make sure that all the atoms around the outside have 8 electrons. And finally, we're going to make sure that the middle atom has 8 electrons around it as well. If there's not enough electrons, and this happens sometimes, we might need to use double or triple bonds in order to make the atoms stable. We're going to now run through 4 examples of Lewis diagrams. The first is F2. Our rules say that the first thing we need to do is figure out the total number of valence electrons in our molecule. Since we have 2 fluorines, each fluorine has 7 electrons, meaning that overall we have 14 electrons total. We're next going to draw our structural diagram. Now we don't really have an atom in the middle because we've just got 2 fluorines, so we're going to draw them side by side. Our next rule says we put 2 electrons between the 2 atoms to form 1 bond, and then we fill the octets of the outer atoms. So we're going to put 6 more electrons around the 1 fluorine and 6 more around the other fluorine. If we count up all of our dots or all of our electrons, it should total up to 14, which it does. So 7 electrons are coming from 1 fluorine. If we take a look here and draw around that one, and the other 7 electrons are around the other fluorine. And you'll notice that 1 electron from each fluorine is being shared in order to form the covalent bond. If you would like, you can replace the 2 electrons that form bonds with a single line instead. So this Lewis diagram would simplify to an F, 2 F's with a line between them, but then we have to show all of the other dots too. So we'd have 6 more around each fluorine, just like so. Our second example, oxygen. So very similar to the last one, we have 2 oxygens. Each oxygen has 6 valence electrons, meaning that we have 12 electrons total. So if we start with our rules again, we're going to draw our 2 oxygens. We're going to do our 2 electrons between our 2 oxygens. I'm just going to put a line in. But then if we start filling up the octets, if we fill up this one here, we've got 2, 4, 6, 8, 9, 10, 11, 12. So we've put our 12 electrons here, but this oxygen's not very happy because it's only got 2, 4, 6 electrons surrounding it, and it wants 8. So in order to get the 8, what's going to happen is another pair of electrons is going to share between the 2 oxygens. And this is going to form a double bond. So the final Lewis structure would be an oxygen double bonded to an oxygen, And then each of those 2 oxygens has 4 other electrons. We would say that the ones involved in the bond are bonding, because obviously they're forming a bond. And the other ones are non-bonding, or also known as lone pairs. This next example is a little bit more complicated because we now have a couple of different types of atoms. NH3, if we start counting up the total number of valence electrons, we have 1 nitrogen. So we've got 1 times 5 electrons, which is just 5 electrons. We've got 3 hydrogens. Each has 1 valence electron, so that gives us 3 electrons total for a total of 8 electrons. Now our rule says the lowest valence number goes in the middle except hydrogen, so that means that nitrogen is going to be in the middle. It's going to be surrounded by 3 hydrogens, so we can put 1 on each side of the nitrogen. And then we're going to put 2 electrons for each bond. So that's 6 electrons placed. And then we're going to check to see if our outer atom valences are filled. Now because we've got hydrogen, hydrogen only has 2 electrons in a full valence shell, so they're already satisfied. That means that the last 2 electrons are going to go on the nitrogen. And so nitrogen now has 8 electrons surrounding it as well. Finally, our last example, our most complicated one, is CO3 2-. If we go through and count up our valence electrons again, each carbon has 4. We only have 1, so that's 4. We have 3 oxygens. Each oxygen has 6. That makes 18. And the 2 negative charge means that we have 2 extra electrons. So we're going to add this up, 18, 20, so 24 electrons total. Our rule then says for our structural diagram, the lowest valence number in the middle, which is carbon. We're going to surround it by the 3 oxygens. We're going to put 2 electrons between each bond. So that's 6 placed. We're going to start filling up the valences. So that's 8, 10, 12, 14, 16, 18, 20, 22, and 24. We've run out of electrons, but if you take a look, our carbon's not happy because it's only got 2 here, 2 here, and 2 here, which makes 6. So in order to satisfy this structure, one of the lone pair of electrons on one of the oxygens is going to share with the carbon and create a double bond. Our final Lewis structure then is going to be a carbon double bonded to 1 oxygen. It's going to be single bonded to the other 2 oxygens. The ones that are single bonded have 6 electrons surrounding it. And the one that's double bonded has 4. So this would be our final Lewis structure. Because it's an ion, we're going to put square brackets around it with the charge outside.